second tutorial sheet. So we are asked to sketch the root locus from these systems below. So from question 1, we got given the gain of the system is equal to 5 over s plus 4. So we have our denominator and our numerator. So our denominator gives us the x pole and our numerator gives us the 0 poles. So if we look at our system, we have a numerator of 5. So when we let that equal to 0, it just comes out as 0 because 5 plus 5 is can't equal to 0, so we get 0. However, when we let our denominator equal to 0, we get s plus 4 is equal to 0, so therefore s is equal to minus 4. So if we come over here, we can see our denominator is minus 4 and our numerator is 0, so we've an x pole at the minus 4 on our graph. So if we come down here, we can see we have our real x-axis on our horizontal and we have our imaginary axis, which is defined by the j. So as we can see from our graph, if we put the x pole on minus 4, which is the sketch of the root locus of that system. So we come down to part B, where we are given a new system. So it's 3 over s plus 4 multiplied by s plus 1. So we do the same again. We let the numerator equal to 0, therefore it goes to 0, so we have no 0 poles, and we let the denominator equal to 0. So when we let the denominator equal to 0, we get s is equal to minus 4 and s is equal to minus 1. So we have 2 points now on our graph. So when we plot the graph, we have an x pole on the minus 1 and we have an x pole on the minus 4. So for part C, our new system is 5 over s squared plus 3s plus 2. So for this one, we have to use our algebra to change the system into something we can recognize and easily work with. So s squared plus 3s plus 2, when we use our algebra, we can get s is equal to 2, s plus 2 multiplied by s plus 1. So then when we do the same as previous, we get numerator goes to 0 and our denominator then becomes s plus 2 multiplied by s plus 1. Therefore we get s is equal to minus 2 and s is equal to minus 1. So when we come over and we plot it on our graph, we have an x pole on our minus 1 and we have an x pole on our minus 2. And we actually notice a pattern here that the poles will never be on the positive side, so the poles will always go to the negative side of the graph. So I'm going to turn over and I'm going to do a next question now. So we have part D, we got 2 is equal to 2 over s squared plus 3s plus 5. So as from this question, if we try to do the same as the previous question, we can't actually make this into a nice easy formula, so we're gonna have to do something else. So what we do is we use the minus b formula and we let a is equal to 1, b is equal to 3 and c is equal to 5. So when we sub that into the minus b formula, so this is our minus b formula here, which is minus b plus or minus square root of b squared minus 4ac all over 2a. So when we sub our values in, we get minus 3 is equal to plus or minus 3 squared, which is equal to 9, minus 20 all over 2. Therefore we get minus 3 is equal to plus or minus square root of minus 11 all over 2. So as we know, we can't square root a minus number, so this is where an imaginary comes in. So if we sub this into, so it then becomes minus 3 plus or minus square root of of 11 I. So therefore, when we put it into our calculator, we get minus 3 over 2 plus or minus square root of 11 over 2 j. J and I are the same in complex numbers. So this is also the same as minus 1.5 plus or minus 1.658. There should be a j in there. So we then come down to plot this on a graph. So when we come down here, we see we have a minus 1.5. So we come over to 1.5. However, we have this j component here, so we actually have a plus or minus the j component. So we have two poles, one on 1.6 plus 1.6, and we have another one on minus 1.6. So then we come down to our last question here. So we have gs is equal to s over s squared plus 4 plus 6. So this is the same idea as before. However, we have now got a s on top instead of a number. So we simplify, we make the formula simpler by adding the 4 and the 6 together. So we have s over s squared plus 10. So we let our numerator again equal to 0. So s is equal to 0. So we have a 0 pole on the s is equal to 0. And we come down to our denominator and we have s squared is equal to, or s squared plus 10 is equal to 0. So therefore s is equal to square root of 10, which then becomes s is equal to plus or minus 3.162. So we come to our graph here, and we have from our numerator we have a 0 pole at the 0 point on our axis, on our real axis and imaginary. And then when we have two x poles at plus and minus 3.16, which are visible there. So that's it for today.